Okay, so we are talking about Merkle tree structures. The AVL tree has emerged as a performance bottleneck. It's a repository that is relatively unmaintained, despite being somewhat playing a somewhat critical role in storing the application state. And so we're going to talk through, a little bit about Merkle tree design. So the key requirement here is that we have a state for which we can generate proofs of substates, so that, for instance, you have an account in the state, you can prove to anyone in complexity that's logarithmic in the size of the tree that some substate exists in the total state. And when we're thinking about these Merkle trees, we want not just to be able to prove things in O log n, we also want to be able to add elements, remove elements, and update elements with the same logarithmic complexity. And so the problem with kind of the standard Merkle tree design, like you find in Bitcoin, is this: it's kind of designed as a static Merkle tree where you can produce logarithmic proofs, but you can't make additions or removals in log n, because you basically end up needing to recompute the whole tree. And there are a few tricks here and there, but they're not really that great or generalizable. And so what you end up doing is looking at more advanced tree structures. So the standard ones, like the radix tree or the AVL tree, which is a self-balancing binary tree, and so on. And you look at ways to actually Merkleize those so that the root node of the tree actually contains a cryptographic digest of the entire structure, right? And so in Ethereum's case, and actually most cases where this has been designed so far, the Merkle tree is implemented on top of an existing key value paired database like LevelDB, right? And so in the case of Ethereum, you have LevelDB, which is your underlying key value store. And of course, it has its own tree structure. So LevelDB is built on a log structured merge tree. So there's a tree there. And then you want to implement a Merkle tree on top of that. And the idea is that every node in your Merkle tree is actually a key value pair in the LevelDB database, where typically the hash of the node is the key, and the value of the node, which is like the serialized node struct, is the value in the LevelDB database, right? And so that way, when you're traversing through your Merkle tree, what you're doing is at each step of the way for each node, you're doing a lookup in the underlying key value store, like in the underlying LevelDB, to actually pull out that node. And so when Ethereum designed its tree, it uses a radix tree. It actually uses a minor variant of a radix tree called a Patricia tree, where I think basically it just means everything. It's just like minor optimizations. But instead of using a binary tree, it uses a hexary tree. And the reason for that is because in a binary tree, the thinking was, if you implement your Merkle tree such that for every step down the tree, you have to do a lookup in the underlying database, a binary tree means you have to do, a large number of lookups potentially to get very deep in the tree, right? And because disk lookups and disk writes are one of the most expensive things you have to do in the Ethereum virtual machine, they wanted to save on this. And so instead they proposed a hexary tree, so that at each level, at each depth in the tree, instead of having only 2 nodes, you actually have 16, right? And so instead of having to travel, say 4 layers down to look up a node, you might only have to travel 1, right? So it basically divides how many lookups you have to do by 4. That's 2 to the 4 being 16. And so that's the Ethereum tree.
The tree, it uses what data for the keys, and to decide in which branch to continue searching? What's in there?
So basically, the leaves, like the thing you're actually looking at, storing in the tree in Ethereum, at the highest level are accounts. So the main data type in the Ethereum state machine is an account, basically roughly the hash of the account is the address. And so in the Merkle tree, the key is the address, which is like a 20-byte effectively random string, and the account and the value is the account, or the serialized account. And Ethereum has its own serialization algorithm called RLP. And so the account is just kind of a simple structure, and they store that in the bottom. But they also do this interesting thing where in the account, they store the Merkle root of another tree, because each account gets actually its own Merkle tree, and that's the local storage for that account, right? So there's the global tree, which has all the accounts, and then each account can also have its own Merkle tree, which is the storage specifically for that account. And so if you want to look up, a particular piece of storage in a particular account, first what you do is look up the account in the global Merkle tree, and that will give you the Merkle root for another Merkle tree. And then you'll go look up that, you'll fetch that Merkle tree, and then look up the key, that you're looking for in that Merkle tree. And in the kind of account level trees, the keys could be arbitrary. Basically, they're actually 32 bytes, but you could really have any kind of structure within there. It's up to the smart contract developer, because the accounts pretty much map to smart contract. Right now, okay, Jarko was asking before, doesn't this exist already? Why did everyone have to go invent their own Merkle trees? Yada yada yada. And basically, at least a couple of years ago, maybe things have started to change a little bit because people have been studying this problem now for a couple of years, but it's still, the case is mostly the same, that typical databases, they do have integrity checks. So they'll take a hash of the whole database so that on startup, they can check that the data is the same as on shutdown so that there is no corruption, but they don't provide the Merkle proofs of like substates. So if you wanted to prove that something was a piece of the database, you would need the whole database so that you could take a hash of the whole thing, which kind of defeats the purpose of what we're trying to achieve. That said, some file systems actually have been using, especially more recently, so ZFS for maybe decades, maybe since inception, has always used a Merkle tree structure for the file system. And so it uses like a copy on write and a Merkle tree so that you actually can prove substates of it. But I don't know if anyone in the blockchain space has actually looked into how that works, or what the API is like for accessing those Merkle roots or for doing those lookups. But you could imagine, for instance, a blockchain application that tied itself to ZFS for its Merkle tree. But there's so many issues around the licensing with ZFS and using it with Linux and all this that it's kind of off the table. But then again, more recently, Apple, I believe, rolled out the same kind of copy on write Merkle tree system in their hard drives. So that's also available. But again, you don't really want to, tie yourself into the hardware, right? So when it comes to actual software implementations and databases that support this, as far as we know, they don't really exist. And so you end up with all these different blockchain projects looking at how to implement their Merkle tree system, right? And so in the way Ethereum did it, they kind of realized a few things after the fact. One is that the design to go with the hexary tree was actually the result of poor analysis of the implementation, right? So it was motivated by the idea that, the implementation is such that every node in our Merkle tree corresponds to a key value pair in the underlying Merkle tree. And therefore, for every step we go down, we have to do another lookup. But that doesn't necessarily have to be the case. You could implement the tree in such a way that you can fetch many nodes at once from the underlying level DB, right? And so you could actually do away with this issue of having to do a lookup for each level. And so, you could fetch like 4 levels worth at once, and then you might actually end up with the same kind of system as you get from the hexary tree, just without it, it would still be a binary tree, but your lookups could be reduced at an implementation level. So that was one thing they realized. And the other issue is that the Ethereum light client proofs are unnecessarily large, because every node in the tree has these 16 slots in it. And so when you do a light client proof, you're only caring about one of the branches, but all the nodes that you have to verify through have slots for 15 other branches that you don't care about, right? Whereas in a binary tree, each node only has slots for 2 things, right? So you're the light client path through the tree, even though it has more nodes overall, each node only has 2 elements in it, right? And so, the Ethereum team has mentioned a few times that they consider this more or less a design mistake, and that in the next generation of Ethereum, they expect to have a much simplified tree structure. So that's the Ethereum tree. So when Jay started out, working on Tendermint and looking at the state of available things, there's another issue with the radix tree, with the Patricia tree, which is that it's not automatically balancing, right? Which means in a adversarial setting, you can attack the tree to force a very large depth, right? And so that can make lookups of certain operations compared to others, like you can really skew the resource cost of doing one lookup versus another. So you can attack a smart contract by, generating a bunch of keys that are going to go really deep down one side of the tree and have other keys not. And, the state machine can't inspect that. So from the state machine's perspective, a lookup in the tree, is all lookups in the tree are equal. And so they all cost the same amount. And so this came up in yeah.
So just to understand the design choice of Ethereum. So what they're saying is, because it's for the light client, they are less concerned about the time than about the space, basically, right? Because
sorry, what do you mean?
Because you said they have to store these 16 slots for each successor, which is a problem of space, right, of memory.
Yeah.
They're apparently more willing to go deeper in the tree than to spend memory. Is this the trade-off there?
You mean in the future? Like in the current design, they did it the other way. Yeah. But in the future, for the light client, you want to minimize the space.
Okay.
Because you basically, the light client's on a mobile phone and it has to sync information over the network, and you want ultimately the least amount of information to have to flow for the light client to get as much security as possible, right? Okay. But they made this trade-off of saying, well, we'll do a hexary tree because it's also expensive for full nodes to do so many lookups in the tree. But then they realized that's actually just an implementation detail. So they could take care of that and get the binary, the binary for the light client. Does that make sense?
Can you just explain how the fact that it's like you have 16 nodes at level affect the size of the light client proof? Because I thought the light client proof is just collection of the hashes along the tree, or one part of the tree.
It's the hashes, but you have to know. You build up your parent nodes, right? So like you get your sister, and using your sister, you build your parent, right? And then you hash your parent, and you get your uncle, right? And you combine those, and you hash that, and then you get your great uncle or your aunt, whatever. I don't know if they're I don't know which gender the nodes are, and so on, right? And so for the aunts and uncles and so on, you're just getting the hashes. But for the direct ancestors, you actually have to compose the node structure itself so that you can then hash it and combine it with the hash of your aunt or your great aunt and whatever, right? And so the larger that node is, the kind of larger the proof ends up being.
Okay.
Yeah.
And so you are doing this upon request, or this is somehow pre-computed? Because when you kind of add a node to the Merkle tree, you can compute the light client proof for that data. And I don't know whether this kind of matters or not, but just.
Sorry, what do you mean? So the light client will say, like, I want to prove, I want a proof of this account. Like, give me the balance of this account and give me a proof that it's true, right? And so the full node will return with the path through the tree, with all the ants that it needs and great ants and so on, and then the light client can go and compose all that. So that's actually right. It's not immediately clear to me where the extra volume is coming in then.
It is, because if I want to prove a particular key in a binary tree, let's say there are 16 nodes in this tree, so it's going to have depth 4. I need to send the value at the key, and then I need to send 4 other nodes, right? Or 4 other hashes of like the opposite sides of the path up in the Merkle tree. But if it's a hexary tree, I need to send all 16 nodes plus the root, right? So that ratio should apply to each like power of 16.
So you are sending hash. You are sending a hash of the opposite tree. That's why, it's kind of the rest. It's not like you are.
Oh, you mean you need to send all 16 siblings?
Yes.
Yeah, right. Of course. But it's only at the bottom. You don't end up having to do that. Oh no, you do have to do that.
You do. It should be like a 5:16 ratio amortized over.
Of course. Yeah. Thanks, Chris. Right. So the other issue with the radix tree is that it's not self-balancing, right? So you can end up having these depth attacks, because it's, it's a prefix tree. So if you have many keys with the same prefix, you're going to get deeper and deeper on that side of things, right? Whereas if you only have, one key with a particular prefix, then it's a very quick lookup. And so what that meant for, the initial security analysis on Ethereum, the resulting advice was that you should hash all the keys before you stick them in the Merkle tree. And this, effectively solves the problem of balancing the tree, because hashes, the output of a secure hash is effectively uniform, and so all the keys are roughly the same length and spread throughout. But the problem now is that you can't iterate over the initial key space, right? And you actually can't even know what the initial key space is unless you keep a pre-image database somewhere, right? And so the full nodes end up having to do this extra work of like maintaining a pre-image database. And if you want to iterate over that, then it's all this extra work, because in the Merkle tree itself, you can only know about the hashes, right? And so you could iterate through the hashes, but that's not really useful in any kind of, meaningful semantic way. Okay, so that's the Ethereum tree. And
the
so
EVM doesn't expose iteration at all, right?
Right, it doesn't. Yeah. Other than through like making a list or a counter and then like using those as your keys and knowing that ahead of time. So when Jay came to this problem in 2014, basically he was like, well, I don't like these issues Ethereum is dealing with. I think I think a better idea is actually to use a self-balancing tree, right? And so he went with the AVL tree, which is a very kind of standard, binary tree that self-balances, so that the weights on either side are always, max off by 1, basically. And anytime something gets too deep, the tree balances out, so that, the overhead there is you have this extra operation of having to actually, do your rotations as you make updates or additions or removals. But the benefit is that you don't have to hash your keys ahead of time. So you can iterate over the actual native key space, right? And the tree stays balanced. But the implementation with respect to an underlying key value store used the same idea, right? So it was a Merkle tree implemented on top of an underlying key value store, also level DB in this case. But you could swap that out. We just use like a generic database interface, right? And so this solves, this simple. Sorry.
So for the rotation, you also have to recompute then the hashes, right? It's not just the rotation with the keys, because there's some semantics in the values.
Yeah, that's right. So you recompute, you end up, if you're doing an update or an addition or a removal, you would end up having to recompute hashes anyway, right? So now you make your update and then you rotate and then you recompute your hashes,
okay.
Right?
Makes sense.
Right. So, it makes the light client proofs more compact, but the tree depth is now much larger, right? And so in the naive implementation, where basically every node in the tree requires a key value lookup in the underlying database, you still have to go deep in the tree, and much deeper than you would have to go in the Ethereum tree, because basically 4 times deeper. Right. So the
naive way to, if you are just fetching one node at a time, like you can do the same thing there. Like I can fetch half of the database and then. Exactly.
So there's a few things to note. So one is that the tree is designed to be immutable. So it's actually, so a couple things. First of all, it's considered, so there's a variant of the AVL tree called the AVL plus tree, where the plus just means that all the values are stored in the leaves. So rather than having values kind of throughout the tree, you just push everything down, and it might make the tree a little bit larger, but at least it kind of unifies the depth, so that everything's kind of at the bottom. I think that just makes things a little bit simpler. And then the tree is also immutable in the sense that because all of these nodes are persisted in a key value database under their hash effectively, when the Merkle tree is mutated, so when an update is made, the old nodes aren't deleted, right? So it's just creating a new node, and then the new Merkle, the new root allows you to basically dereference that new node, but the old node still exists in the database. So if you still have access to an older Merkle root, you can still get to the, you can do lookups and proofs at any previous state, right? And so that's where the immutability comes from, and that's why we call it an IAVL plus tree, right? Yeah. So, so very quickly you accumulate all this state because you have the full Merkle tree structure from every height. Now, of course, you're not replicating the whole tree at every height. You're only, it's basically a copy on write system, right? So you're only adding new nodes, and then at any time, the Merkle tree might reference, nodes that were created at a large number of different heights in the past, up to and including now. And then you could start to think about, okay, how can we actually start to garbage collect on this thing, right? So maybe we only want to keep the last 100 nodes or the last 100 heights, so we can throw away nodes in the tree that aren't referenced by any of the nodes within the last 100 heights, right? And so the IAVL tree library has basically a garbage collection mechanism that the user can specify some kind of protocol for when, or some kind of schedule basically, for when they want heights to be deleted. And so the tree kind of tracks these orphaned nodes, which are basically nodes that aren't referenced anymore by a height that we're paying attention to, and then they can be cleaned up and deleted. But then, of course, that means you'd no longer be able to do lookups corresponding to that height. So, so I think that's basically the overview of the system. Anyone have any questions? Then we can start talking about the performance.
And so the Orphan Node is the one when you create a new version of like new value for some key, then the previous one becomes orphan, essentially.
Correct. Yeah. Yeah. And so if you only want to keep the current height, then you could throw away those orphans, right? But if you want to keep the last 10, then it wouldn't be considered really an orphan here until there are 10 more updates to the same node or something, right?
Just as a point of curiosity, would it be easy to alter the garbage collection algorithm to take into account the subset of the key space, like to keep a longer history for a particular subset of the key space if you wanted that at the application level?
I don't know. Maybe. I'm not sure. Yeah.
There's relevance here for stuff like IBC, which sometimes benefits from the ability to look up past subsets of trees.
Right. That's an interesting question. It might be, so in the SDK, the structure in the SDK, so again, if you recall from Ethereum, they have this global Merkle tree, and each of the leaves is an account that references its own Merkle tree. So you have basically a Merkle tree of Merkle trees. In the Cosmos SDK, there's a similar kind of structure. There's a global Merkle tree that's actually just a simple kind of static Merkle tree, and the leaves of those are these dynamic Merkle trees like the AVL tree. So in the Gaia application, we actually have multiple Merkle trees, one for each roughly module. So there's a Merkle tree that stores information about staking. There's one that stores information about governance, and so on for the different modules. And so, at that level, then you could say, well, the IBC Merkle tree is going to persist, for a month, whereas the staking Merkle tree only persists for, a week or a day or every 1,000 blocks or whatever you want. So you could provide different schedules for the different trees. Whether you could easily do that to subtrees of a given tree, I'm not sure. It's probably possible, but it just might not be worth the complexity.
Mm-hmm.
Yeah. But the really nice thing about the Cosmos SDK and using a tree like the AVL tree is that iteration is native to the system. So you can actually iterate through the tree, through the native key space, and not worry about, a pre-image database or anything like this, because things are actually stored under the native key. Now, one thing I forgot to mention that's super important and is probably one of the major drawbacks of the AVL tree is that it's not insertion order invariant, right? So in other words, it's insertion order dependent. So the Merkle root of the AVL tree and the structure of the AVL tree actually depends on the order in which you inserted the keys and values, right? And this has significant implications for things like state sync, right? Where if you're trying to sync, if you're trying to read out key value pairs, if you just listed all the key value pairs and gave them to another node and said, here are all the key value pairs, make a Merkle tree out of them, you'd almost certainly compute a different Merkle root than the original because of the nature of the rotations. You end up with a different structure, which means a different Merkle root overall, right? So there was some work being done into, well, how can you serialize the key value pairs so that even if the order doesn't match the order that they actually went in, it gives you an order that results in the equivalent Merkle tree structure, right? And it's actually not that hard to figure that out, but you just have to make sure it's kind of done correctly. And so that's possible, but yeah. Sean?
So every once in a while, the IAVL tree is going to like do this rotate operation. Is that true?
Mm-hmm.
So upon doing that happens on insert or asynchronously?
It happens on any kind of update.
Okay.
No, sorry, it happens on insert or deletion, I guess,
Okay.
yeah.
And then if on rotate, it's going to change the parent-child relationship between nodes. Is that also true?
Yeah.
So it has to recompute some subset of the hashes.
Mm-hmm.
So like the complexity of how many things do I need to do on write is kind of non-deterministic, or there's like a worst case, but it could be really on write.
Yeah, I mean, the big O is still log n, but you may, because you don't have to, you just might have to do an extra, 2 things at each step instead of 1, right? So you just end up with a factor in front of like at most 3 or something.
Of 2 writes, but if you rotate, so say you have like worst case in my head is like, say it's all going down the right side or something, like all children, maximum depth, right? No siblings. And then obviously it wants to reorient that. Isn't that going to be more than a factor of 2?
Yeah, but it never lets you get there because basically it rotates as you go so that the maximum distance is like 1, right?
That makes
So
sense.
as soon as there's a difference of 2, it does a rotation.
Yeah. Cool. Thank you.
Yeah.
But
Cool.
So this seems like the issue with AVL tree in general, not just with our implementation of it. Just
The insertion order?
Yeah.
Yeah. It's a
So
drawback of AVL trees in general.
there are no AVL tree which sort of have kind of deterministic mechanism for.
Not that we know of, because the nature of the rotation is such that it makes it dependent on the insertion order, because you get different results depending on how you rotate. So I don't know that anyone. So Alexei, who built okay. So now we can start talking about the performance issues, and that basically brings us to Alexei. So Alexei is this like brilliant engineer who shows up in the Ethereum space, and it's like, what are you guys doing building a tree on top of a tree? Like, that's not smart. So let's go try to do this properly and build like a real database that just has Merkleizing built in. He's like, thinking about hardware and paging and all this kind of stuff. He's like, well, let's store a bunch of nodes together in a fixed size object called roughly a page. And you store and load pages as a single operation instead of this nonsense of like every node is an independent key value in a larger underlying key value store and all this kind of stuff, right? And so that kind of optimization is one of the keys to his basically fork of the Go Ethereum code base that he calls TurboGeth, that has a very highly optimized state database where he's applied a lot of his analysis of the tree to dramatically reduce the number of lookups and the latency of lookups and so on by kind of amalgamating the 2 databases, so that instead of it being a Merkle tree on top of another key value store, it's kind of a single thing that has a Merkle tree implemented into a database structure, right, using pages and just like smart stuff here. So and so then we had him to start, we were engaging him to work on Ethermint, which is basically our, Go Ethereum on Tendermint. And obviously we were interested in using the optimizations he had from TurboGeth, but we wanted Ethermint to be built using the Cosmos SDK. That was one of the kind of key design requirements of the Cosmos SDK, was that you could build the Ethereum state machine identically to the current Ethereum state machine without any changes, so that you could literally replay mainnet Ethereum transactions and get the same results using this Cosmos SDK framework as kind of the architectural setup for how the different pieces connect, right? And so in doing that, though, there's this store interface as part of the Cosmos SDK. And we have yet to, as far as I know, actually maybe it happened, but we have yet to make an adapter for Ethereum's Patricia tree into the store. So we ended up using our AVL tree as part of the Ethermint store. And so, that brought Alexei basically back to square one to start looking at the AVL tree and seeing how we could apply the same kind of optimizations to the AVL tree. And that led him down a bit of a rabbit hole of investigating Merkle tree structures and optimizations and how to implement that in databases, and comparing the different kinds of Merkle trees, and which one is, what the different trade-offs are across all of them. And also really looking into this insertion order invariance issue for the AVL tree, and realizing that you could encode elements of the structure of the tree into the nodes themselves, so that you could, so that when you reconstruct the tree from the key values, you can actually, attach basically, I think it was like 2 bits per node to be able to know what the structure of the tree should be, so that you don't necessarily have to serialize it in a particular order. You just get this extra information out of it. So he's done like kind of all this analysis, and we were lucky to have him for a few months working on this, but he's been kind of sucked back into working on Ethereum. Maybe the correct term is saving Ethereum. This video is going to be public, so I should probably watch myself, but the Ethereum community is very lucky to have Alexei. So there's that. So, so meanwhile, we're kind of, back to this position where we have this AVL tree. Not much work has been done on it in quite some time. We're now facing performance issues around it, similar to the performance issues Ethereum was facing. We're now, starting to talk about the state sync stuff. The insertion order dependence has a big impact on state sync, because you can't just sync the keys unless you serialize them in the right order, and so on. So the main thing that seems to have emerged with the as an issue with the AVL tree from a performance perspective is what people have identified as compaction time. And so this is basically a level DB artifact, I guess. So because it's a level DB, uses a log structured merge tree, which means basically that it has like multiple layers of of files, I guess. And as nodes, as things get added to the tree, over time, they kind of collect in these files, and the files eventually get kind of compacted and moved into the next layer, right? And so you have like values in the tree progressively moving through these layers of files where they're kind of more and more compacted, right? And the compacting, has all this indexing involved with it, and basically, the newest things are kind of up front, so they're it's quick to write them. And then over time, as more and more things collect, they kind of get compacted and compressed in this way and moved into the next layer. So it's still possible to query them quickly, but they waited a while to do a bunch of the heavy work on writing, right? And so the impact of this is, yes, you can initially write very quickly, but it leads to potentially very large write amplification further down the road, because this compaction operation results in quite a bit of work and quite a bit of disk IO. And so what people are noticing is that the AVL tree, after a certain size, or after the blockchain has been running for a certain amount of time, the level DB compactions start to take up a very, very significant amount of processing time, and that this is becoming a real bottleneck. And so people are starting to look at why this is the case. And we haven't done really focused experiments ourselves, but a few people have reported on swapping out level DB for other alternatives like Badger DB, like C level DB. So right now our level DB is written in Go, and I think there are some known issues with that, but folks have tried using the C level DB version, and they've tried Badger DB, which is a different database design, but written in pure Go. And that's actually what backs, I think it's called dgraph, which is kind of a graph database that's exploding in popularity. So very, popular production product. But even with those, there's still performance issues. And, it seems that one of the key reasons here is that because of the way we store nodes as, in the underlying database as under their hash, where the hash of the node is effectively the key. And because the hash changes every time the node or its children change, it means the locations of nodes in the database are constantly changing. Nodes are basically constantly being reindexed because their identifier is changing, right? So rather than giving every node, for instance, a fixed identifier and being able to look it up under that, every time a node or its children changes, the identifier changes because the identifier is the hash of the node, right? And so that, people are starting to identify that maybe this is really a key cause of our performance issues, is this constant reindexing of nodes within the tree, of changing their location and having to move actually where they're stored. They might have been compacted into the database and then you update them and now they're under a different hash and you have to put them somewhere else and whatever. And so, so one question is, well, can we actually build this? It's still maybe, all of this is still basically a Merkle tree on top of another tree, right? So that design in and of itself is probably questionable. But, assuming we're going to stick with a design like that and we don't kind of consolidate the two yet, is it possible to have the nodes have a persistent identifier so that they're not constantly being reindexed? And if so, what would that look like and how much work would it be? And would it be worth doing that compared to, re-architecting the whole relationship between the Merkle tree and the underlying database and kind of combining them?
And so regarding this, what Alexei was doing on more or less kind of doing this, which for me seems like a proper way, like just trying to design things based on the Merkle tree and then figuring out the right storage mechanism there. We haven't made any progress more or less with respect to ABL tree with respect to this, or like this turbo get stuff. Like it's really like something very Ethereum specific, so we can't really reuse those work ourselves. Right.
Unless we adopted Ethereum's tree, but then we would suffer from the problems of the radix tree. The main one, I think, for us being the issues with iteration. And that's not, there's iteration is rampant in Gaia and the SDK. We're constantly iterating over things. And so having to store a second pre-image database just to support that, now maybe a different analysis would apply with respect to the attack surface of using a radix tree or a non-balanced tree. Certain aspects might be very difficult or even impossible to really attack there. But, that would be we'd have to be very dangerous analysis. Yeah.
So in terms of requirement we have there, so we won't have this more or less log-n complexity for all operation we have there. And so the relying on the underlying database, which has its own, philosophy about how they store data and doesn't really care or know anything about this log-n requirement have, seems like super hard, to figure out. And the second one is so because of state sync, we have requirement that the insertion order needs to be somehow captured by the tree itself, I guess, because unless we don't care about this, if we do the state sync where we just serialize everything to byte array, then we don't care about this. But in case we want to do the other option for state sync, we need insertion order to be somehow encoded as part of the tree. I guess what Alexei was kind of suggesting. Mm-hmm. So it seems like that we need more or less to figure out requirement we want from the tree itself to be able to talk a bit more what are the design options there, because it's not the same whether we want to capture insertion order or not, for example, and then also these performances, is it a big problem from the SDK point of view if the operation takes much longer than in the kind of normal case? The fact that you are sort of amortizing these costs over time, is kind of this a big problem? I don't know, from the attack point of view or because it seems it's not just performance here, that just you want to kind of guarantee more or less similar access time to if you use this tree. Because from the application point of view, all operations are log-n, so more or less they should kind of have
the same.
Exactly.
Yeah.
So
yeah, that's right. Although one somewhat different approach, which we did consider briefly, but certainly didn't pursue yet, is to pass the gas calculation logic through the tree and have the tree itself track it as an integer counter. Well, I don't think it would add that much overhead. Like, it's not going to add overhead compared to the disk IO. You're just incrementing some register value as you're progressing through the tree. That's an interesting alternative way to guard against like particular attack vectors potentially.
So basically, then you could use a binary radix tree, but you just count the depth, so that if someone tries to make the depth really high, you're going to pay for it.
That's right. And in a sense, you would almost defray the optimization task to the application layer, or at least the SDK layer of developers design applications, which would result in the tree being quite well balanced. It will be cheaper.
Right.
But this doesn't save you from the fact that although the tree is balanced, the underlying data store might, because of the way how it manages data, do this kind of compaction or whatever, which screw up your access time, basically.
Right. Yeah. Right. Yeah. Now these things tend to be like pretty much all the trees are more or less like universally, they try to do everything in log n. So then we have log n on top of log n, but then there's that doesn't really account for like the latency issues around the write amplification, or the compaction. Yeah. So I haven't really looked in detail at how BadgerDB compares, say, which is a slightly different design. I think they're basically, if I recall, some kind of variant of a log structured merge tree that's written from scratch and is very different from LevelDB, but shares some underlying principles. But I think they still have some form of compaction that that would probably also suffer from. So it seems at the end of the day, if we're going to stick with a tree on top of a tree, we should be looking at if it's possible to have persistent IDs for the nodes so that they're not constantly reindexed, and or alternatively re-architecting the thing from scratch so that it's not a database on top of a database, but they're kind of somehow more integrated. But that's a larger project, and there's no one here dedicated to it.
I wonder if it is worth looking at, and I really have no knowledge of this, but what ZFS does. ZFS is a really production-capable file system. I'm guessing that the people who built it know more about databases than anyone in this call, and possibly anyone working in
the world, maybe,
except Alexei.
Yeah.
It would be interesting to see what they did.
I do know some guy who should be able to tell us a bit more about this, like kind of from the scratch approach. And so it might make sense to talk about that. But I think that we have state sync as a sort of like something we need to figure out in the next few months. And so like re-architecting the IVL tree from scratch, I think it's
I don't think it's an option.
I think it's kind of nice discussion, and I think that one of the follow-ups should be that we should find some people who really understand this stuff. Yeah. And I do have some idea for this, but it's more like a kind of research. But like short term, we need to work with what we have, and then try. For me, this insertion order seems like a more kind of it's something I'm worried, unless we are going for the other option for state sync. And then you're right, these persisting IDs seems like something we can do, I guess, relatively easily short term.
Mm-hmm. Yeah, so it might be worth trying to look at that. Now, other possibility, like the main place, as far as I understand, the main place this is an issue is when you're trying to fast sync. Because then you're running many, many blocks at once, and that's trying to go very quickly, and then, it can really slow things down. So there could be some optimization you can do around fast sync where you just don't persist the whole tree as often, right? You just like wait 100 blocks before you actually go and try to persist the thing. And that might be a really easy way for us to, take some of the pressure off. Now that would require that, and this has already come up as an open issue, that would require that Tendermint, tells the application that, hey, these blocks are coming in through fast sync. So, you can spare some cycles or something.
Also with With nodes that archive nodes, nodes that don't have pruning enabled, essentially also suffer from this problem.
Oh yeah, they're screwed. Yeah.
Once they get like past 100,000 blocks, it halts pretty much.
Really?
Yeah. Or close to it. And we need those kinds of nodes. So.
And we need those kinds of nodes. Yeah. So that's concerning. Yeah. So, yeah, I don't know where that leaves us. At least, we. I hope everyone has a better understanding of the thing now than coming into it.
Yeah, that was phenomenally educational. Thank you.
Yeah, you're welcome. And I don't know exactly how we're going to address it. We'll have to take that up in some kind of planning session and maybe speak with the rest of the team and some community members about how we ought to do this. Yeah, it's
Do we have
definitely a real
the
challenge.
ability to contact Alexei, or is he?
Well,
very
it depends. Probably our best hope is if we all join, if we all stop what we're doing, start working on Ethereum 1.x, ship that, and then get Alexei back. That might be the path of least resistance to solving our database issues. So yeah, depends on how much the Cosmos community wants ETH 1.x to ship. Hopefully that's high. I think it's probably high. But
we'll find another Alexei, but I'm more worried the fact that we don't have anyone who is kind of responsible for this part of the code, and I don't know, this is kind of a problem. So even if we organize next session with kind of more details, who is really in charge of this and who is who gonna push this thing.
Yeah.
So this is probably something which needs to be first fixed. Who want to take responsibility for this thing and then try to go slowly and fix one by one issues there.
Yeah, and it's also the kind of thing where there should be no part of the code where there's only one person working, right? So you basically need two people. And in the past, we sort of tried to create like a quote unquote low level libs team to focus on these things, and it sort of evaporated for unknown reasons, but organizational restructuring and so on.
Do we have a very clear requirement? Sarko said what are the requirements? This is the way to go forward, basically. Have a very clear set of requirements. What are the features this database should bring, and what are the read and write operations that happen? Do we have a very clear picture of that? And are they always equal for all use cases we use the IVL in?
I think more or less. At this, the thing satisfies what we need out of it from a user perspective. The problem is the performance is terrible. The performance is fine initially, right? But once the thing gets large enough and there's enough history, these reindexing operations are just, a death knell. So somehow addressing that, we could frame the requirements in terms of numbers, don't stop, don't halt. So we could, we can summarize this discussion and kind of try to write down what we've, this overview and what the requirements are and what the problems are. And folks in the community have started writing these things up in the issue.
And I'm also wondering if something like a sparse Merkle tree that does not rebalance, but instead keeping a second data structure, like a list that keeps track of the original key space and the insertion order, if there wouldn't be a very simple yet fast solution to what we need?
It could be, yeah. So we didn't talk about sparse Merkle trees, and I haven't really investigated them too much, but Ishmael, do you want to explain them?
Yeah, I can give a very rough overview. A sparse Merkle tree is just a full balanced tree, which is where the leaves always exist, but they're empty. And when you insert something, the empty leaf gets replaced with whatever value you inserted, and otherwise there's still a leaf, but it's a placeholder thing, it's empty. And depending on the hash, you can think of it as a perfect triangle, which always is full, and so it never needs rebalancing. Insertion is just computing a hash, say SHA-256, and then you get the you use the hash to find the position and where to insert, and that's it. And this, I think, this doesn't give you the original key space and the insertion order again, which is problematic as far as I understood. But keeping this in a list and storing this separately, at least insertion and everything would be very fast.
So why we don't have the pre-image in this case, like original?
Because the keys all have to be like 32 bytes or something, right?
Yeah, exactly.
Yeah. So you have to standardize the key space somehow, and the natural way to do it is with hash. But you could use padding or something, right?
You could, yeah. Why would you?
So that you can preserve the keys. But then I guess you don't know. Yeah. Couldn't you do that?
I would keep, like, the original keys are not hashes, right? Or are they?
Suppose they're not.
Okay, if they're not, I would keep them separately, like, because you still want the hash to have like the exact. I mean, the hash basically makes up the tree, so you wouldn't pad the original keys or something like this. At least I wouldn't. Just my gut feeling. I didn't think this through at all. But
Right.
if the keys can be anything, then the keys should be stored separately. And when you look up a key, you hash it and you get the position in the tree.
And so this, you mentioned that, so this thing exists, or you are proposing to more or less replace it?
This concept exists, and there are a few implementations of that. The only one I'm familiar with is developed at Google, which is in the Trillion repository. You can send it in the chat or something like this. And I think Merkle trees are similar, but I don't know how exactly they work.
And regarding insertion order, like, is this the issue in this kind of tree or not? We don't have problem with insertion order.
Yes.
We do have still.
We don't.
We don't.
We would need to keep track separately.
The insertion order doesn't matter, but you can't iterate unless you track the pre-images.
Okay.
Is that what you're saying? I'm asking.
I didn't say anything.
No,
But
because
That sounds accurate.
Right. That's my impression, that it's insertion order independent. But
how insertion order is independent when it depends on the ordering, like, of values you have. It's like very value dependent where you would put a thing. The fact that you have like empty values doesn't prevent you from.
well, it does, because there's only one structure for the tree, and it's determined ahead of time. Like, it's basically a tree of size 2 to the 256. So, the tree is bigger than the size of the universe.
Okay.
And the structure is determined ahead of time for the empty tree. And then you can start filling things in. So as far as I can tell, the insertion order doesn't matter, but you don't know the keys in the tree are separate from the native keys. So it sounds like you're supposed to hash the original key and then you put it in the tree. But assuming you use deterministic hash function, you get deterministic ordering and so on.
So you mean like the somehow tree structure or this intermediary nodes, they have like a fixed value more or less upon like creation time. And then when you have a new node, you need to find just the place where it would be there. But you don't need to rehash all the stuff on the way.
I'm not sure exactly.
Okay.
I think you have to do some rehashing, but there's no rotating. So the positions in the tree will be the same, but you probably still have to do rehashing. So I don't know that this would solve the persistent intermediate node index issue. But because there's a fixed number of nodes, no, but there's too many. So it's 2 to the 256. So you can't just number them.
But just to stay oriented, is the problem we're having that rehashing too many nodes upon insertion is expensive, or is it the compaction of the underlying SS tables?
My understanding is it's the compaction, because the indexes of the nodes keep changing every time there's an update. That causes issues for the underlying thing, right? Yeah.
You know what Cassandra is doing? Because they had that problem as well.
What Cassandra is doing?
Cassandra.
Why? So why did they have that problem?
They also do, what's it called? Memtable plus LSM trees or whatever. That's what they hold their key space in. And they and they replicate SS tables across nodes. And so they had I think they were trying to develop some tooling around bootstrapping new nodes. So similar to our fast sync, you have a state where a node is live and you're getting insertions in sort of small increments, right? But then there's this other asynchronous case, which is doesn't happen so often, but could potentially bring down the network if it's too slow. Say some portion was a network partition, and that you know that you need. I don't know if you guys are familiar with Cassandra, but just imagine you have
Not really.
a partition data set across a cluster of nodes, and then you need to make sure that each one of these partitions is available on some replication factor. So all your nodes are responsible for sending something to these new nodes to populate them, right? And I think they did some work around making these snapshots that would avoid a heavy compaction. Because if you were to say do the dumb way, let's just stream writes to the new nodes, right? Then you would hit all these compaction tasks, which was a huge area of research on Cassandra. I wonder maybe that could be a source of inspiration outside of the crypto space.
Yeah, that's really interesting. It sounds like maybe a different problem, but the solutions they might hit on could be similar or might end up helping. Yeah,
because it seems like the fast sync thing is it. Could you frame it as needing to bring a node up to speed?
Yeah.
Okay, so it seems similar in that way.
Yeah, I guess it's more. It sounds like what they're doing would be more similar to the state sync, which we haven't actually even implemented yet. With fast sync, we stream the transaction history, and basically each node rebuilds the state by running the transactions against the state machine.
And when we can't batch that, we can't have a snapshot of the effect of a set of transactions applied. We can't.
That's what we call state sync. So instead of syncing the whole transaction history, we just send them the current state. Yeah. And that basically sounds a lot like the Cassandra issue.
Precisely. Yeah. And then there's the diff between it starts when you give a snapshot, but you need to catch up a little bit.
And then you catch up with transactions after. Yeah. So we'll always need the fast sync, the transaction sync, so that you start the state sync, you finish, and then you do the transaction sync until you get to the latest state or the latest height, and then you can do consensus from there.
Do you have a link, Sean, where this is described in more detail?
I will make myself a to-do to send out an email follow-up.
Just post it in the notes, I think.
Yeah, I can post it in the notes. I just don't have it.
Context is directly there then as well. Thank you.
So, right. So there's a few ways to kind of work around this in some sense, which are all, hacks in one way or another. But one thing that is, this is kind of a segue. One thing that has been in high demand from, sorry, I'm not supposed to say demand, highly requested from the SDK team, and could kind of help here in a weird way, is to allow Tendermint to start from a non-zero height. And basically what this means we can do is just every so often throw away the history and restart from the latest state. And that way we can kind of avoid this problem of keeping so much historical state and continuing to update. Now it basically shifts the burden in a completely unmaintainable way. So this isn't by any means a sustainable solution. For instance, if you have archive nodes, you're gonna and you want to do this dump state restart operation every 100,000 blocks, you're gonna end up with an archive node for the first 100,000, one for the second 100,000, one for the third, and you're gonna have to leave all of those online, and then you're gonna have to put in front of it some kind of front end that can multiplex requests to any one of those back end. So you're just gonna move the burden to an operational problem or to be someone else's service problem, which isn't great. So it's obviously something we need to solve. But in any case, there's a number of reasons why we actually need Tendermint to be able to start from a non-zero height. Probably the most, the strongest one is so that we can make breaking changes to the state machine without changing the chain ID. And so basically, you know, suppose at height 100,000, we want to now go and make a radical breaking change to the state machine where, you know, now, you know, I don't know, the number of validators is 200, or, you know, the inflation rate changes, or some new governance protocol, or whatever the case may be. The current situation, what we would do is we would dump the state, start a new blockchain from height 0 with a new chain ID. And if we did not change the chain ID, all of the validators starting at height 0 would now, you know, be eligible to be slashed, because they're basically double signing at all those heights for the same chain ID, right? And so, you know, if we want to be able to continue the chain ID, which is going to be important in the realm of like IBC, once we have many blockchains, we want each blockchain to be able to kind of persist its identity for, you know, a longer period of time, even through potential upgrades and so on. Then this kind of non-zero Tendermint height would need to be possible. So in this scenario, basically you would have, you know, Tendermint's been running for 100,000 blocks, and then you want to basically stop it, and you basically start it again from this new application state. And so you would dump the application state at height 100,000, and then you restart Tendermint, and now Tendermint is supposed to be starting from height 100,000, where the application basically has no notion of anything below 100,000, right? So as far as the application is concerned, you know, it's starting from scratch, but the effective height it's starting with, which is just like an integer it uses to kind of stay synced with Tendermint, is 100,000, right? And so this opens up, you know, a number of questions. Like, for instance, should Tendermint continue to preserve the transaction history before 100,000, even though the application it corresponds to is different than the one that's running from height 100,000? Or should Tendermint just make a clean break and say, you know, this 100,000 is effectively height 0 for me, and just, you know, prune all of the older history and put the burden onto, you know, some archive node or something like this. So these are questions I haven't quite resolved. I don't know, you know, it depends a little bit more on kind of the user story, I guess, on how this should happen. I've started going through the code to basically be like, okay, what would it take to treat a different height as height 0? And because we have, you know, we assume implicitly all over the code base, essentially, that the first block is height 1 and the genesis height is effectively height 0, right? And so the only approach I know of right now to actually start dealing with this is to be grepping for all uses of the number 0 and the number 1 in the code base, and see if it's corresponding to a height. And so that, you know, this is what I've started doing. I've gotten pretty far, and, you know, so I'm just kind of marking them as I go with, you know, start height in all caps as a replacement for 0, and then we'll figure out how that's actually going to be threaded through. You know, because presumably now the Genesis file is going to have a height field, which will tell us, you know, this is the initial height. But we still have to answer this question of, you know, what is the effect of that height from Tendermint's perspective, in terms of, is it just the application that's starting fresh at that height, or is Tendermint also going to throw away all its history and start fresh from that height, or is it going to keep the history but somehow treat it differently from the history, you know, after that height, or what? And I don't really know the answers to that.
But there are several questions here. Like the first one is just that the initial height is not always 0. And so we need to support at the Tendermint code base to treat this in a sort of generic way. Because we have, just for like context for the others, we have several rules which are kind of asymmetric with respect to the initial height.
To the first height, yeah.
Yeah, like first height is kind of specially treated at several places in a code base.
Yeah.
So like,
but you know, this is a lot of those reasons are because we have this kind of off by one thing everywhere, where each block contains stuff from the previous block, especially the commits, right? Now, obviously, you can't avoid having to refer to the block hash, the previous block hash. So even if we got rid of some of this off by one stuff, we'd still probably have, it'd still probably be a special case. So I guess
it would still be there. Yeah, it would probably still be there, because like initially we don't just have some field set up or it doesn't have meaning, so we need to treat it differently. So I think that we can't avoid this. So I think that probably the first thing here is to identify those cases and to sort of parameterize the initial height so that we can support this case. And then the other question is, or the other questions are, and what it really means, like, do we clean or not? What we do we prune the blockchain or not? I think this is like, this is probably the different kind of questions. But like probably as a first step, we can try to identify, and it seems what you did like is probably the most reasonable thing. We just need probably like several eyes looking at this and trying to see.
Trying to think if there's some way we could have missed it or something.
Yeah, exactly.
Maybe we also need to look for twos. I don't know. I hope not. Yeah.
So the question I have is on the trust. So as far as I understand, right now you just basically trust the Genesis block, right? And then from there on, everything is signed and you can continue. Now, if you throw away these prefixes, are you going to trust any height that is started somewhere?
So it's a good question, because it's actually not true that you can always just trust the Genesis block. Because the proof of stake security model, it's actually quite similar for a full node as it is for a light client. If you're joining a new network for the first time, you have to have a subjective root of trust, or what's the new word we're using, Chris? Validation predicate?
In IBC, consensus state and validity predicate, yeah.
Right. So you have to have this validity predicate, which is like this subjective piece of information that you verified socially, that is valid within the unbonding period from your current time, right? Basically the same as the light client for getting started. And so if the Genesis block is only less than 3 weeks away, you can start from the Genesis block. But if you're more than 3 weeks from now and you start with the Genesis block, well, then the Genesis validators could be sending you fake information, and there's no way really for you to detect that other than hearing from others, and there's no way for them to get punished for it. You can detect it eventually, but they could fool you. So this is somewhat mitigated in production right now by the fact that the validator set is like relatively stable, and if anyone reported an attack, even though people wouldn't get slashed for it, there would be significant reputational fallout. So we're sort of biding our time on the altruism of the community and the kind of nascency of the community and so on. But this, adding this
we hope it's mitigated in production, If I were to attack the Cosmos network, I would form a validator cabal now and prepare the double signatures, but not release them until IBC was enabled. Like a DEX was connected, right?
Yeah. We're not going to launch IBC until we sort these issues out. That's for sure. Yeah. But, if Cryptium tried to join forces with a bunch of the others to, make an alternative history of the Cosmos Hub, I don't know that people would take very kindly to that. I mean, maybe you guys would argue, well, this thing should be, resistant to adversarial whatever. And then, Brian will have you on Epicenter to talk about how disingenuous you are because you're the core developers that were supposed to fix this stuff in the first place. So
I agree there's currently significant reputational fallout.
Yeah. So this basically happened. This was what I'm referencing. So, Sunny, who's works at All in Bits and worked on the economic model and all this stuff, is also running a validator independently of All in Bits, and he set his commission to 0%. And Brian, who runs Epicenter, actually with Sunny, but who's also running a validator, was very displeased by this, race to the bottom. And so when on the podcast we actually, me and Sunny went on as the guest. So Sunny got to be a guest, and Brian brought up this point and kind of grilled him about, what is this conflict you have? And, it's so brutal that you get to design the proof of stake and then you get to set your commission to 0. And then, it's a big mess. And so I think Sunny defended himself kind of well, but yeah, it was fun to see Brian just like really grill him on that. Anyways, yeah, so I'll push something soon with respect to my initial annotation. It won't compile because I'm literally just sticking in a all caps variable. We could start by making a global variable, setting it equal to 0, and just at least we have a variable into the code as a way to get started to then think about how to refactor to actually, inject that height in at the various places. But, it's like something I can't even write an ADR for it yet because I don't even know about all the places where it matters. So it's like, first I'm trying to find all the instances in the code, and then we can start to look at it holistically and think about how to organize, this idea of a non-zero height, a non-zero initial height. So I guess there isn't really too much to report there, but I guess that's a work in progress. And related to this will also be kind of independent of the state dump and restart is just pruning the blockchain itself. So how we'll think about throwing away old blocks and then not making sure that you can't, you're unable to query for that. And then of course that will require state sync so that, because if nodes don't have the old blocks, they can only sync the state. And so all of these things are kind of interrelated. Yeah.
What's the level of effort you think, Bucky, so far, based on your observations?
On the non-zero height thing?
Yeah.
How do you want me to quantify level of effort?
Like how many places are you seeing right now where we have these explicit checks?
A lot. Like dozens.
Okay.
Because I searched for zeros and I searched for ones. Maybe I'll do a sanity check on twos, but I don't think there'll be any twos.
We did use a constant for that, like initial block height? No?
Yeah, something like that. But it has to get passed in everywhere. I mean, presumably we don't want it to be, it's not going to be constant because it'll be read from the Genesis file. So it becomes like a consensus parameter, essentially. So actually, maybe that's the way to do it, is make it a consensus parameter. And the consensus parameter is actually available everywhere as part of the state. And so that's probably, yeah, cool. I didn't think of that before. So that might be the best way to do it. I'm actually going to write this down.
My guess is somehow that it's related with the validation of the block, and I'm not able to figure out like also a little bit inside consensus that we for initial height, but even there I'm not sure. Like there is no really difference. It's more like you also have the rules for round zero, so you might be getting some of those when you grab for zero.
Oh yeah. I'm just parsing through, and it's like if it's a round, I skip it, and
Exactly.
I get when I grab for 0 and 1, I get thousands of hits.
Yeah.
So I'm basically doing it one package at a time, and
But like, what would be the
parsing
example?
visually.
Yeah, what would be just one example, which is not about like the block validation, and it's about initial height.
Well, let's see. Okay, I'm looking locally. Do you want me to just push this right now, and then we can look at the diff?
Or just share screen with us.
Sure. You see? So I already made a commit. I'm tracking it in wait, what? I'm tracking it here. So basically, these are the packages I'm working through. So I've done 0 and 1 on everything except types. I've only done 0 so far. And so in this commit, I did all the zeros, and in my current working tree, I'm doing the ones. And so if I look here, here's something where I'm not sure. Here's like need proof block. So this is for the consensus, no empty blocks, create proposal block. It's different if it's the first one. So there's basically a few cases where, besides validation, where the behavior is slightly different if you're on the 0th block or the first block. Here now we're in the state execution, the validator info, well, if you're on the first block. But so this is the thing, right? Because like, if it's genuinely block 0, then there's no validator info. But if the start height is now X, because there was the previous block actually exists, then we actually can still get that info, right? So, even though the start height is X, we actually did make a block somewhere at X minus 1. And depending on how we deal with things, we might be willing to actually use that information, right? So, we might end up with multiple conditions where one is, is this height 1, in which case it's genuinely a unique thing, or is it height, start height plus 1, in which case maybe we still have access to the old block so that we can create this, or maybe we don't, right? Like in a, yeah, because presumably you'd still want to be able to fast sync, you'd still want to be able to sync the chain through one of these changeovers, right? you would just need, like, at a particular height, you'd have to update the application so that you can keep going, right? So from there, it's almost like you want Tendermint to continue. So even already, you know, I don't know, you know, Bez and Chris, like, isn't this something we can already do by just stopping Tendermint at a height, updating the application, and then restarting? And then, you know, Tendermint doesn't even need to know that it was like a non-zero restart.
Possibly. Thanks. Maybe. I'm not sure.
Because presumably we would want, well, maybe not. I mean, in some cases we want to just throw away the whole history and start again. Mm-hmm. In other cases, we might just want to continue the history. And in yet other cases, we might want to throw away the whole history, start again, but still have a link to the old history, in which case the last block, the information from the last block, we still keep around. So it's actually still available here. So this, you know, off by one, the height 1 is actually different from the non-zero height +1 because we have access to the old information. So
don't we always want to,
Don't we what?
Don't we always want to keep the previous block before the restart?
That's what I'm saying.
We do that linking?
Probably, yeah. So we can do that linking, yeah. So exactly, you know, what that should look like and how it should be done and how much of the history we're trying to throw away, and are there different, you know, are we trying to offer different options here? I guess needs a little bit better specifying from like a requirements perspective. So, you know, anyways, I'm still going through and trying to identify all these things because it's anyways probably valuable to see this, you know, this the distinction or this case logic, and to have a variable for it. But, you know, this stuff is just initialization, saving state makes a difference whether it's 0 or 1. A lot of it's pretty much always because it's a question of whether or not we have the old information. Yeah. So if we have so we might actually be able to eliminate all of this case logic if we just always define the old information, even if it's with empty values, right? So that's actually maybe the better way to go about this is to make sure the initial information is always there. It's just with default values or nil values or whatever the case may be for height 1. Yeah,
if we have a meaningful default values.
If we have meaningful default values, yeah.
But yeah, but like, I'm trying to understand really like why we would not be able just to update the state. So if we are at some height, we commit a block, we compute the state, and then at that point, I guess if we update the state, just continue for the next like a block, it would be the new application state. Why would be this problematic? Can someone see the issue there?
Well, it just means if you then try to query the state at an older height through Tendermint, the application might not have that information available. So I guess it would just return an error, but Tendermint doesn't necessarily have to know anything about it. So there's just a few subtleties around what the user should expect after that changeover. I mean, on first thought, it seems like totally possible that Tendermint could just continue without any change, and all that has to happen is we stop so the app can update, and then we continue. And basically the version would have changed, and so on, the app version, which isn't actually very well integrated into Tendermint yet. So that's something we need to think about too.
So I have a question which was not totally clear to me. Who is picking the height of the new blockchain that is started?
The validators, the application, some on-chain governance mechanism.
Because so in principle, I mean, there's a problem, right? If they pick a value which is in the past, for example, that should not happen, right? Or if they pick something in the future, then it might be weird that there are, you know, heights with have no single block in there.
So they would assume trust in the chosen height to some degree.
Yeah, they would like pick a height in the future, and then everyone would shut down their nodes at that height, so they make sure they don't create a block at h+1. If they do, then, you know, they're shit out of luck. They'll have to change the chain ID, otherwise they'll get slashed unless they want to wait 3 weeks to start the blockchain again.
Something that you sort of you give some control and possibly weird behaviors to the application that you would not have if you know with Sharko's approach where you just stop and basically rearrange the application and start where you went from now.
It seems like just the question is how much we want to sort of align Tendermint with the application, because in general we don't care about application. And so from that point of view, if you update the application, it will be reflected starting from the next height, because like through the proposal mechanism. But then, yeah, as we also are sort of front end to the users, then user might kind of be surprised. But I don't really understand. We would need to define what might be surprised means.
Yeah. Yeah. So it might not be a problem. From the perspective of, though, if we want to throw away the whole history, then we still have this issue of we need to be able to start from a non-zero height. Otherwise, we have to change the chain ID.
Because right now it seems like that one sort of so just one kind of requirement, which it's not clear whether we want to provide or not, is that if you query at some height application state, and then later in time you do the same query, that the result might be inconsistent.
Yeah, you might get an error the second time because the application will tell you, oh, we don't have this information anymore. But that's already the case because the application could be pruning, right?
Yeah, that's already the case.
So it's already something that Tendermint can't control and that the user might just be surprised by. So it's like an application level thing.
Yeah, I think past height queries are not a feature that most full nodes actually need. Archive nodes do, and like nodes backing explorers do, but regular users.
Yeah. But like queries like validator sets, for example, or queries that are directly to Tendermint, those could error out, right? If you prune the history.
If we prune the history, yeah.
Yeah. And why is that a requirement exactly?
To be able to query historical heights?
No, to prune the history. Like, why is that a consideration?
Oh, because it grows unbounded. We make too many blocks.
All right.
Yeah, I mean, if we fix the time stuff, and then we turn on no empty blocks, that could buy us a lot of time before we have to think about pruning history. But then once all the blocks have once there's enough transaction volume that we're still making blocks every 6 seconds, we're going to get back to the pruning the history problem, right?
Yeah. Okay.
And at some point, the history becomes less reliable because it's you've got the long range proof of stake stuff, right? So I mean, we could be hashing it into Bitcoin and making archive nodes and stuff deal with all of this, but yeah. So it seems
over IBC. I have a design for this for another
for fetching history over IBC.
Yeah, like some kind of tiered cache layer over IBC with progressively more expensive to access but cheaper to store.
Interesting. Okay. So, I mean, it sounds like we need to do a bit more writing around these interrelated issues of pruning and updating the app, the relationship with state sync, and yeah, I mean, so really the non-zero height thing, I guess, falls under pruning. It's really about the pruning strategy, which we can't really roll out until we have state sync. I mean, we could, but then it's kind of pushing it onto the application developers to figure out how to sync their state independently, like out of band. But we're trying to solve that problem for them anyway. So, because otherwise, with respect to like, if all we want to do is update the app and we're happy to keep the history, we should be able to do that already without any like non-zero height thing. We just stop the nodes and update the app and restart them. Right? Yeah. So we can look a little bit into that. Okay. So that's good discussion. So we have another 20 minutes here. How do people feel? Should we keep going? Should we talk about some PRs? The work Bez has been doing, community PRs, amino plan. We've got this list. I don't know if anyone.
Just for me, it'd be nice to see you guys review PRs and like what you guys look for. I've never seen it live.
Cool. I don't know if we've ever done it live.
Me neither.
All right. So should we review a community PR? Yeah.
Sure. Yeah.
Great. I guess I can share my browser.
Would the list of lists count as a community PR?
We could review that one.
Well, you're employed by all bits.
It's not really a community PR, but we could go through that one. Should we do that?
We can go through any other community one, maybe something simpler.
Okay. So I'm not sure. I mean, I could just pick a random one. Oops.
It's fun zombie.
So, you know, this doesn't refer to an issue, which kind of bothers me, but it seems they wrote a detailed kind of thing here. But ideally they open an issue, they write about the issue, you know, they write the problem and how they propose to change it, and then they open the pull request and all they have to do is reference the issue. Or if it's, you know, if the pull request is only going to address a piece of the issue, then they could write about that. But in any case. So here, alters the startup behavior for the crawl peers routine. So this is about the seed mode. So when you start Tendermint in seed mode, it basically crawls peers. So it's like crawling the network to find addresses. Previously, the routine would crawl a random selection of peers on startup, but for a new seed node, there are no peers. Makes sense. As a result, new seed nodes aren't able to bootstrap themselves until another node with list of peers connects. If this node relies on the seed node for peers, then they'll not discover anything. Okay. So very smart. So let's look at this change. It looks pretty small. So I don't know if this one is going to be useful, but because it's so small and probably straightforward. And so I'm just trying to get this thing out of the way so I can actually see it. Zoom won't let me. Zoom won't let me move the zoom off my screen, so I have to pull this in a bit. All right. Okay, address book is empty and no seed nodes. So I would, try to look here. So this actually isn't checking. This actually isn't checking if the seed nodes are empty, right? So he's
on the bottom.
What's that?
You think that do that on the bottom?
Well, but he changed this error to say address book is empty and no seed nodes. But it's not clear that there's no seed nodes if seed address here is. So at this point, I would go open my. Can you see my? I guess I should actually just share my desktop. There we go. You can see the terminal too, yeah? Mm-hmm. All right, so let me just, share screen. Okay.
Continue typing.
Huh?
Continue typing.
Okay. So I was going to check out what's going on here. PEX reactor. And then this check seeds function. So, this is the key thing with reviewing PRs is that you can't actually just look at the diff because, unless you literally have the entire code base in your head, you need to know. So here, basically, so this is our list of seeds. Okay. And we return, grab the seeds from the net address, look at any of these errors. And I think if it's I see. If it's 0, we'll return -1, 0, 0. And so, yeah, so I don't think his comment is right. So then I would say,
But Ethan, what's num online there? It's in the number of seeds.
num online exceeds L seeds minus length errors. But it could actually miss something, right? So if we returned here, we would return a -1, and that's definitely no seeds. So I don't know why, num online returns -1 if no seeds were in the initial configuration. Whereas if there's some kind of error, we'll return 0, and then otherwise it's the number of seeds minus the number of errors. So if they all error, then we couldn't connect to any of them. So this error message would be more clear and better synchronized with the result. Check seeds. -1 to indicate no seeds from all seeds different from failing.
Well, for -1 will be a non-nil error, so you don't hit them. Anyway, I'm just.
They would otherwise be error. It would be non-nil. Or it would be nil, right? So it's like, okay, so we have to look at this, and this function maybe needs to change to adapt to what he's trying to do, right?
That's a problem. Yeah.
Yeah. So yeah. Seeds could return -1 and a nil error to indicate there are no seeds, which isn't captured here, for instance.
Shouldn't the method check seeds return an error to indicate that there are no seeds, and then like a error that can be checked against?
Probably.
-1.
Let's see where check seeds is. Yeah, so it seems it's only used in this one place, and so so maybe we can say something like check seeds could be better. Check seeds should probably do a better job of returning errors. For instance, seeds and using yeah. So in general, it's probably better to avoid these like special case like integers. It's kind of abusing the error system and so on, right? But seeds is only used in this one place, so yeah. And then here, basically, he's just being explicit, I guess. So that's fine. That improves check seeds. And then finally, attempts to dial, do an initial crawl. So if we have any seed nodes, consult them first. And then otherwise, crawl peers. So that makes sense, I think. Great. I don't know why my internet's so slow. Cool. What else? Should we do another one? I mean, that one probably wasn't that informative. And, probably could have used more time to actually think about that check seeds and maybe propose something better for it even. Yeah.
So Ethan, we only have 10 minutes left. I was just wondering, for community PRs, I don't think there's any difference than all the other PRs we do, right?
No, not really. The only difference is that they weren't necessarily scheduled, and so they're not necessarily a priority from a like roadmap and planning perspective. They're a priority from like keeping community engagement high and like getting active contributors, so that eventually active contributors might be willing to take on things that we scheduled on the roadmap or on the milestones. But otherwise, it's it's just someone wrote code. It's probably good.
Yeah, I'm just wondering why should we do community PR reviews during the Thursday meetings versus just do them, I don't know, prioritize them such that we get to them and do it the normal way.
That's a good point. Yeah, we could just, there's no reason to do community versus internal. We might as well just, we could spend time on these calls reviewing PRs that we wrote. For instance, this one. This one seems to have accumulated quite a bit of comments already.
It would have been actually very interesting to see like how you go through that big refactoring. Maybe it's too late. It's already 112 comments, probably most.
Well, I think a lot of these came from the linter, the new auto linter thing. So a lot of those have been addressed, but I think I left a review with like 20, 30 comments, and that was only on a third of the PR or something. So it's a massive PR, and there's a lot of really good work in it. And Jarko's been reviewing too. So I guess, so we can be reviewing our PRs. Maybe that's a good thing to do. I'm not sure what to do with these final 10 minutes. Anyone have any thoughts? Should we just call it early?
But going back to community PRs, what's the alternative than spending time in the Thursdays? Do you want to have some kind of assignment for us to get one PR a week, or I don't know, rotation?
That's a good idea. I guess as PRs come in, we can say that we'll all take on one community PR per week, and we'll see it through until it's done, and see how that manages the load, basically. Some of them, the person, they only have so much time. So like this guy, we left a bunch of feedback. He said, okay, he's doing it in his spare time. So now we're waiting for him to respond. So whoever would have been responsible for that should then pick up a new one.
And the definition of a community PR is a name that's not part of a core Tendermint, or are they marked?
I guess it's someone who is not employed full-time, as far as we know, on the project by entities whose financial information we have some limited access to. It's very vague. I don't know how to define, we're talking about multiple organizations here now, right?
Worst case, we're reviewing a PR that's ours. There's no harm done, but...
no harm done, for sure. No, it's not well defined. It's like if Iris... people from Beyondgy contribute a PR, like, are they internal? It's hard to really say. They're external. They have people full-time working on this stuff. They maintain forks and so on. And they have a production network using our software. So the lines are really blurry. I guess it's more about if someone contributes a PR that is outside of the current scheduled, outside of the current milestones, the current set of milestones, then maybe the word isn't community PR. Maybe we call it something else, unscheduled PR or something like that. And we can try to carry some of those as we're working on the actual scheduled stuff. Depending on the value or importance of it. If they're fixing a bug and improving something, it's probably worth bringing it in. If it's some large change that, we plan to get to eventually, but, it's too soon, then, maybe forget about it. Cool. Anything else? This was good. So full 2 hours, covered a lot of ground. I enjoyed it. I don't know about the rest of you. It seems like there's pretty good engagement. So
this was super helpful for me to see you guys interact. So thank you for that.
Cool. Yeah, that's good to know. Yeah, if you have any feedback or suggestions or anything that you don't want to share, with the whole team or even with the whole internet, because this will go live at some point. And let me know.
It was great. Could we have a mandatory 1 minute stretch break at the 1 hour mark?
Yeah. Anka actually mentioned that last time, and then we blew right through it. So yeah, good stuff. Sure, let's do that. All right, cool guys. Thanks for your time and engagement and mental energy, and we'll see you online.
Cheers.
Cool.
Bye guys.
Thanks, guys.
Bye.
Bye.